Good evening to all. In the previous lecture, we have discussed regarding the classification of polymers based on source, based on molecular structure, etc. Now we are going to discuss the important topic, that is the plastics, and based on thermal behavior, the classification of plastics, etc. So, first of all, coming for the plastics. So plastics are generally high molecular weight organic materials and which can be molded into any desired shape by the application of heat and pressure in presence of the catalyst. That is, the plastics are generally high molecular weight organic materials. So they are high molecular weight organic materials which can be made into any desired shape by applying either heat pressure in presence of a catalyst. So plastics are high molecular weight organic materials that can be molded into any desired shape by applying heat pressure in presence of a catalyst. So that is what we say as the plastics. So generally we know the plastics which we are using based on the thermal behavior, they can be broadly classified into two types. One is thermoplastic, that we have already discussed, and thermosetting plastics. So now we are going to see regarding what is thermoplastics and what is thermosetting plastics and what is the basic difference between thermoplastics and thermosetting plastics. Okay, now thermoplastics, so they soften on heating. That is, when heated they become soft and become hard and rigid on cooling. So after heating, when we cool again, they become hot and rigid. So by reheating again in the suitable temperature, they can be softened and reshaped and reused. So thermoplastics are nothing but they become softened on heating. When you heat the thermoplastics, they become soft. So after heating, when you cool the thermoplastics, they become hard and rigid on cooling. They become hard and rigid. But again, when you reheat the thermoplastics again to a certain temperature, they can be reshaped or remolded. So they again become softened. So such is that is the main characteristic of a thermoplastics. That is, they become softened on heating and again become rigid on cooling. So again heating to a certain temperature, they again become softened. So that can be reused in number of times. So these thermoplastics are usually soft, weak and less brittle. They are soft, weak and less brittle, and they are mainly soluble or organic solvents. They are soluble in organic solvents. They are mainly formed by addition polymerization process. These thermoplastics are prepared by addition polymerization process. So thermoplastics are nothing but they become softened on heating and again become rigid or hardened on cooling. So again by reheating or repeating the heating process again, that can be reshaped or softened or reused again. So they are soft, weak and less brittle, and they are soluble in organic solvents. So they are formed by mainly addition polymerization process. So next, coming for thermosetting plastics. So thermosetting plastics are become permanently hardened on heating, and once they become set or hardened, they cannot be softened again. So thermosetting plastics or sets, otherwise we say, they become hardened. Once you heat the thermosetting polymers, they become hard, and on again heating, they cannot be softened again. So once the process is performed, they become hard and they cannot be reshaped again. So they are hard, strong and more brittle compared to the thermoplastics, and they are insoluble in organic solvents. Thermosetting plastics are nothing but they become hardened or gain strength on heating, or once become set, they cannot be softened again. So once you heat the thermosetting plastics, they become hard, and after the heating process again, if after that also when you heat, once they become hard, they cannot be softened again. And that was the characteristic property of the thermosetting plastics. And they are hard, strong, and more brittle, and insoluble in organic solvents, and they are generally formed by the condensation polymerization reactions. So this is what the basic difference between thermoplastics and thermosetting plastics. So thermoplastics, once heated, they become soft and becomes hardened on cooling. So when you heat again, it becomes soft again, so they can be reused. But in the case of thermosetting plastics, once you heat, it becomes rigid, and again the process cannot be repeated. So this is what the basic difference between thermoplastics and thermosetting plastics. So look at these pictures where in the picture we have the differentiation between thermoplastic polymer and thermosetting polymers, where in the case of thermopolymers, only the weak intermolecular forces between the polymer chains are there, but in the case of thermosetting polymers, we have strong covalent bonds. That is, once the thermoplastic polymers are heated, this weak intermolecular forces are destroyed, and they become softer. But again, on cooling, it can be reframed again. But in the case of thermosetting polymers, they are held together by strong covalent bonds. So once the bonding is getting collapsed on heating, it cannot retain the structure on again. They cannot be softened again. That is what the basic difference between thermoplastics and thermosetting. So weak intermolecular forces in the thermoplastic polymers, and in the case of thermosetting polymers, we have strong covalent bonds. And we have as basic classifications. So examples for thermoplastic polymers, we have polyethylene, polypropylene, polycarbonate, polystyrene, etc. Thermosetting polymers, we have vulcanized rubbers, epoxide, polyester resin, phenolic resin, etc. So now we are going to see the basic differences between both thermoplastics and thermosetting plastics. So as I already discussed, thermoplastics are prepared by addition polymerization, but thermosetting are prepared by condensation polymerization. Thermoplastics by addition and thermosetting by condensation polymerization. And thermoplastics usually contain their long chain and linear structure. So thermoplastics have linear and long chain linear structure, but in the case of thermosetting plastics, they have three-dimensional network structure. So thermoplastics have a long chain linear structure. Thermosetting plastics will have a three-dimensional network structure. In the case of thermoplastics, the polymer chains are held together by weak van der Waals forces, but in the case of thermosetting plastics, they are held together by the strong covalent bonds. So thermoplastics, they are weak, soft, and less brittle. The thermosetting plastics are, on the other hand, strong, hard, and highly and more brittle. Again, in the thermoplastics, they soften on heating and harden on cooling. They do not soften on heating again. And thermoplastics can be remolded n number of times, but in the case of thermosetting plastics, they cannot be remolded. So once heated, when it acquires the desired structure, it cannot be remolded again. And thermoplastics, they generally have low molecular weight, but the thermosetting plastics have high molecular weight. So these are the basic differences between thermoplastics and thermosetting plastics. So thermoplastics, they are formed by addition polymerization. The thermosetting plastics are formed by condensation polymerization. In the case of thermoplastics, they have long chain linear structure. In the case of thermosetting plastics, we have three-dimensional network structure. In the case of thermoplastics, they are held together by weak van der Waals forces. In the case of thermosetting plastics, they are held together by strong covalent bonds. Thermoplastics are weak, soft, and less brittle. In the case of thermosetting plastic, they are strong, hard, and more brittle. In the case of thermoplastics, they are softened on heating and harden on cooling. They do not soften on heating. Thermoplastics can be remolded. Thermosetting plastics cannot be remolded. Thermoplastics have low molecular weight, and thermosetting plastics have high molecular weight. So this is what the basic differences between the thermosetting plastics and this is what the basic differences between thermosetting polymers and thermoplastics and thermosetting plastics.